Yes, let's continue. Let's do the derivatives of the exponential function. Alright. So any questions on those 6 problems that you practiced on?
6.
They were pretty easy. Number 6?
Sure.
Alright, so look at 6. What form is number 6 in? It's in log form, so I have to rewrite it in what? Exponential form. So what's the base of ln?
1/2.
E. So this is like e to the first is equal to that, right? So e to the first is equal to the square root of x plus 2. How can I cancel out the square root? We square it. If I square this, we have a power to a power, so that makes us what? Multiply the power, so that's e squared equals x plus 2. And then we just minus 2 and we're done. That was easy. E squared minus the 2 is equal to the x. Yes? Okay, very good. Got it? Alright, so those are some skills that we're going to need later. So that's why we were practicing that. You will not need it for the derivatives of the exponential functions, but we will need it later when we're trying to do sign lines and we're trying to get critical numbers and we have to equal and solve an exponential or a logarithmic function, okay? That's what we practice. Alright, so let's look at the rule for derivatives of natural exponential functions. You ready? Yeah? Maybe? Alright, let me borrow those really quick, just to make sure we do it the same way, we don't get confused. Alright, so the general rule for the derivative of e to the x, it's really simple. I'm going to write it the way I did the log one. So the derivative of e to something, okay, is going to be e to the f of x. So you start off by just rewriting the problem. Oh, that's easy, right? Times the derivative of whatever the power was. Is that hard? Times ln of the base, which in this case is what? E. So ln of e is what? 1. So in calculus books, you will not see that ln of e there. You will just see e to the f of x times f prime of x. Or you could think of it as u, right? So if it's e to the u, then it would be e to the u, u prime. Yeah? Cool? What if I want to apply it to a function with any base? What if it's something that doesn't have an e? Would it be the same thing? Yes, it's the exact same thing except that this won't be an e anymore, it'll be whatever the number is, right? So let's write down that rule. So for exponential function with any base, okay? So let's say I want the derivative of a to the f of x. That's going to be just what? Rewrite the problem, a to the f of x times f prime of x times ln of the base, which is a. Super easy? We're not going to be working with this one right now. We're going to be working with problems that all have a base of e. So technically we can forget about that part, but we shouldn't forget about it because it is part of the formula. Okay? Pretty good? Do a couple of examples and then we're done? Yay! Alright, so here we go. Look at the first one. F of x equals e to the sine of x. So what do we start off with for the derivative?
Rewrite it.
Rewrite it. E to the sine of x times the derivative of that sine of x.
Cosine.
Cosine x. Oh my god, we're done. That's it. That was easy. It would be times ln of e, but ln of e is just what?
1.
1. So we're good. Try the next one. We made it back. So what's this derivative going to be? How do I start it up?
Rewrite it.
E to the 2x plus 3 times the derivative of the stuff?
2.
2. So that one we can rewrite and put the 2 in the front and just say 2e to the 2x plus 3 just because it looks a little nicer like that. Okay, but mathematically they are equivalent to each other. Good? Alright, let's try the next one because we're doing too many easy ones. What's this one going to be? The 3 is just a constant, right? So he stays there times the derivative of this guy. So what's the derivative of e to the 2x? E to the 2x times 2, right? So you're multiplying by the derivative of the exponent. So what does that become? 6e to the 2x. Super easy. Alright, now let's get interesting here. So the next function, if you look at it, it is the what of two functions?
Product.
The product, right? So I have to use what?
Product.
Product rule. Oh, how fun. So let's do it. Product rule. Derivative of the first. 2 times the second. Plus the first
2x.
times the derivative of the second.
E
to the 3x. Times 3, right? Okay, so let's see if we can simplify some of this stuff. Here we get 2e to the 3x, right? Plus, this will be 3e to the 3x, right? Times 2x plus 3. I just put that part in the front and put the other one on the other side. Is that okay? I didn't actually multiply or do anything. So can we do something to this?
You could
Can't combine, but can we factor something out?
mm-hmm.
Yeah, what is it that they both have in common?
2 to
2e to the 2x?
the 3x.
No, just e to the 3x. So take out an e to the 3x, and what's left over? 2 plus 3 times 2x plus 3. Okay. Can I keep going? Can I do something inside to simplify that part in there more?
Factor.
Yeah, we can distribute this 3, right? So that'll give me 3 times 2 is 6, and 3 times 3 is what? 9. So we got 6x, right? Plus what?
9.
9 and 2. I'm going to write it out. We got 11 plus 6x times e to the 3x. And we'll stop there. The reason you want to go that far is because, like I said, later on we're going to be finding critical numbers. And remember, critical numbers are where the derivative is equal to 0 or undefined. Would this derivative ever be undefined?
No.
No. But could this derivative ever equal 0? Yes. So let's look at it. Will this part ever equal 0?
Yeah.
No, right? We showed you the graph, right? E to any power will never be what? 0, so don't worry about that. But can this inside here be equal to 0?
Yes.
Yeah, when x equals negative 11 divided by 6. That's my critical number. I have one critical number, I do my sines line, and then I can figure out stuff about the original function. So it's like the other problems, but now they're more complicated derivatives, a little bit different stuff. You understand? Alright, let's do these last 3 examples before we leave. So what is this next one? What do I gotta do there? Product rule again? Alright, let's do it quick. Derivative of the first.
2x.
2x times second. Plus the first. Derivative of the second.
I don't know how to say this to you. I'm just like E2X.
E to the 2x times 2. Are we good or did I go too fast?
We go faster.
I went too fast? I need to go faster?
Yeah.
I'm sorry. So this is 2x e to the 2x plus 2x squared e to the 2x, right? These two guys multiply. So now looking at those two terms, what do they have in common? What can I take out? A 2 an x, and then e to the 2x. Okay, what's left over? 1 plus 1 plus x? Okay, so now if I want to know where this is equal to 0 so I can find my critical numbers or my horizontal tangent lines, right? Can the outside equal to 0 now?
Yes.
Yes, this is going to equal to 0 when x is what? 0. Because when I put 0 there, that'll give me 2 times 0 times this will be 0, right? And when will this be 0? When x equals -1. So how many critical numbers are there for this problem? 2, right? Okay, and remember what happens at critical numbers. We could have relative maxes or minimums, right, at critical numbers. Or they could just be a horizontal tangent line, right? Might not be a max or a min. I would have to check the signs. Cool? Alright, let's do this last one here. Okay. How could I rewrite this one, Ale, before I start? This would be the same thing as e to the 2x minus 6 to the 1/2 power, right? Well, what's the rule about power to a power? Multiply the powers, right? So can I multiply half with this?
Yes.
See what we get? What's half times 2?
1,
So that's just x. What's half times 6?
3.
Oh, so this is just like e to the x minus 3? Alright, that made my life easier. So sometimes you want to apply some properties or some laws of exponents to simplify the problem before you get started, right? So now let's find the derivative. What's that guy going to be? E to the x minus 3 times 1. Oh my god, so we just get the same function again? How weird. So the derivative, the slope generator, is exactly the same as the original function. How cool is that? So it's kind of like if I were to plug numbers into the original function and all the points that I would get, well, all of those y values are actually the same as my
Slope.
slopes of all the tangent lines at those points, right? Pretty cool. Pretty cool. Good? One more? Alright, let's do this one more, this last one here. So this last one here, what does it look like we're going to have to do on this one? Oh, quotient rule. We couldn't leave home without doing a quotient rule, right? Alright. It's almost Friday. It's hump day actually. It's Wednesday.
I was like, is it Friday today?
Yeah. Alright, so what is quotient rule? I say the word, you tell me what to write. Low!
3x squared.
3x squared. D high!
E to the 5x.
Very good. So some of you are already getting fast enough to put that 5 in the front. Cool. So e to the 5x times 5, it's okay. Minus high. D low. All over low. 3x squared. Squared. Alright. Can we simplify some stuff? If I multiply these two guys, what do I end up with? 15 x squared e to the 5x. Okay, minus 6x e to the 5x. All over, let's square this. 3 times 3? 9. X squared times x squared?
X to the
X
4.
to the 4. Okay. Is there something we can factor out on the top?
3.
A 3? That's it?
An x.
A 3, an x, and an e to the 5x? Oh my god, all that stuff? Times, what's left over?
5.
5, x,
Minus
minus
2.
2, all over 2a, no. All over
I always say that.
X to the 4.
I'm always like, oh.
9x to the 4th. Okay, can we cancel something else out? We can simplify the 3 and the 9, right? So this 3 goes away, this 9 becomes a
3.
3. What else? This x goes away and these 4x's become
3.
3, right? So now we're left with our final answer, e to the 5x times 5x minus 2 all over 3x to the third. So now this one, can this derivative be undefined?
Yes.
Yes, where would it be undefined? At 0, because that's the number that will make my denominator 0, right? Okay, where will it equal to 0? Can this ever equal to 0? No, but can this guy equal to 0? At what value? 2 over 5, right? So my critical numbers for this problem would be 2 over 5 and 0. Those are the possible places where I could have a relative min or a relative max. I would have to do further investigation by making a sign. You want to make a sign line? No? We'll save that for later?
Yeah.
Okay. Alright, so that's it for the notes. Okay, I want you to do the rest of the problems on the assignment, which entail finding derivatives and equations of tangent line. So give them a try. Be careful on 15, okay, it's e to the x and then plus 1, okay? The 1 is not up there on the exponent. I got those confused when I was working it out in the other class. And then they were like, oh, but it's not up there, and I was like, oh man. Okay, so don't make that same mistake. Cool? Got it? Alright, so practice that. We have some time right now, and we will finish tomorrow. Actually, you know what? Let's fill in the foldable. We forgot to finish doing this.